We're going to do 6.1 first, which is talking about these radical functions, or actually just square root functions. The first problem, and I actually wish there was more than one, is talking about the domain of a square root function. Now, remember, when you are dealing with a square root, what's underneath this square root has to be a positive number if you're going to physically graph it on the graph, right? Because if what's underneath here turns negative, what happens? It turns into an I, right? If you have an I, where are you going to plot points for that? You're not, right? It's actually going to give you an error message in your calculator for anything that turns what's underneath the square root negative. So anytime that you have a square root and you're asked to find the domain of it, it has to be positive, or another way to say positive is greater than or equal to 0, right? Because if you're greater than or equal to 0, you're a positive number. If you're less than 0, that's when you become a negative number. So on number 1, it says to find the domain of the function f of x equals the square root of 5x plus 8. So if I'm finding the domain of this, what I'm concerned with is what's underneath here has to be positive, or what's underneath here, which is 5x plus 8, has to be greater than or equal to 0, right? That's what makes you positive. So whatever that is, just set it up as greater than or equal to 0, and then solve it for this x, which means you would subtract the 8 from both sides. So 5x is greater than or equal to negative 8 divided by 5. So x is greater than or equal to negative 8/5, okay? And it is multiple choice, so what you're looking for is make sure you find the correct symbol. That's how you choose A, B, C, or D. And then put in the negative 8/5. Now, the rest of these are graphing these square root functions. The only thing that's tricky about some of these is that in every single question is multiple choice, but the graphs may not look exactly like the graph in your calculator, because remember when you were graphing in your calculator, your view is called the standard view, right? The x and y axis, what does your x-axis start at? It starts at negative 10, goes to positive 10. Same with your y-axis. It starts down here at negative 10 and goes up to positive 10. And each hash mark goes by once. So keep that in mind when you are graphing these. Like number 2, it says to graph the function f of x equals 3 times the square root of x. I'm actually going to put that in my y equals. So go to y equals 3. Now remember where square root is. It's the x squared button, but it's right above it. So you just need to hit your second button first. So second square root, put your x in there. Now let's graph it. So the square root function looks like that. Now, when you look at A, B, C, and D, there's a couple that look similar, or actually 3 of them. B goes in the wrong direction, right? But look at A, C, and D. Also, notice that every single one of these hash marks look what your x-axis does go from -10 to +10, but look how many hash marks there are. There's only 5, which means their hash marks are going by 2. Oh, that's fine. So just put in the X. Sorry. So, okay, look at, I'm going to change here. That's fine. That's perfect. All right, so I need to put the top 42. So this one, so the x-axis does go to +10, but its hash mark, there's only 5 hash marks, which means in between their hash marks are 2, right? That goes from 2, 4, 6, 8, 10. Same with their y. 2, 4, 6, 8, 10, 12, 14, and then it has a 15 right there. So when I plot these, let's go ahead and look at our table. So hit the second button and then the table, and let's plot a couple of points. Look at there. What happened there? Look at that. When x is -1, what's the y? It's an error, right? Because what happens if you have a -1 in there? It's not in the domain. Can't be -1 because what's underneath here can't be negative. That's why you're getting those error messages on anything below 0. So I'm going to plot a couple points. 0, 0 is where it starts. 1, 3, 4, 6. I'll plot those 3 points. 0, 0. Now, 1, 3. Remember, this is not 1. That's 2 on their graph, right? So 1 and then up 3. Which is in between the 2 and the 4. This is a good point to look for, though, because it's 4, 6. So 2, 4, and then up 2, 4, 6. This is a good point to look for when you are choosing your graph, because especially when you're dealing with MATLAB, you'll have the magnifying glass to be able to blow that graph up, right? So this one, at the point 4, 6, because it's going to be on hash marks and not in between them. So that one would match the C graph. Some of them you're going to be able to tell by just looking at the graph without having to plot points. Let's look at number 3, like number 3. Number 3, the function is f of x equals -2 times the square root of x. What is this negative going to do to this square root shape? What does the negative do? It's going to flip it upside down, right? That's what the negative in front of the x does. It's flip it upside down. There's actually only one graph that has the square root flipped upside down, isn't there? Yeah, only one of them does. So again, if you put that in your y equals, if you go to y equals and change it to -2 second square root x and graph it, you'll notice that it is a square root, but flipped upside down. Okay, so in this one, since it was multiple choice, there wasn't any need to plot points because there was only one that had its square root upside down, which was A. What do you notice about number 4? It's the same problem as number 2. So we've already done it. Not any different. Except the answer is D on that one instead of C. All right, number 5. square root of x minus 6. So that minus 6 is an inside number, right? What does our shifting rule tell us about inside numbers? They shift us left and right, but we go opposite the sign. So that minus 6 should shift the square root to the right 6 places. Again, you just have to be careful on the multiple choice. Look what their graphs go by this time. Five, 10, 15, 20, right? So they're going by 5s this time. So if I shift it to the right 6, but these go by 5s, it's just going to start a little bit past that first hash mark, isn't it? If I put it in my y equals, if you go to y equals and clear it out and type in second square root x minus 6. And then if you have the parentheses, go ahead and close it. I didn't know some of them have parentheses. Go ahead and close it. So this one, when I shift it to the right 6, it's going to look different than the multiple choice options, right? Because my hash marks on my calculator go by 1. So there's to the right 6. This is still to the right 6. It's just that the first hash mark is at 5. Does that make sense? So which one is that? To the right 6 would be B. Number 6, f of x equals the square root of 2 plus 2x. I'm going to graph that. I'm going to plot points here. I'm going to go to y equals, clear it, type in second square root 2 plus 2x. Let's see what this looks like when I graph it. There's my square root. I'm looking at my multiple choice options. I know it's not B because it's not a line. I know it's not. Actually, you know what it is by looking at your multiple choice, right? Because what C and D are wrong also because why? Right. They don't even have the right shape. Where does this one start? So we're going by 2s again. 2, 4. So if I go to second table to start getting points, the first point that's not an error is -1, 0. And there's another one at 1, 2. And another one at 7, 4. So this one starts at -1. So it's actually starting a little bit to the left of the origin. Okay, which is a good distinguishing point when I'm picking out from those multiple choice. To the right 1 at 2. Right 7, so 2, 4, 6, 7, up 2, 4. So again, the distinguishing, I think the most distinguishing point on this one is that the actual square root function starts a little bit to the left of the origin in that. Last one. That's why we're doing 5-4 today. Square root of 8x minus 8. So go to y equals and put in your new function. So clear it. Second square root, 8x minus 8. Perfect. So this time you'll notice this one starts a little bit to the right of the origin when I put it in y equals. So let's get some distinguishing points there. So this one, x can't even be 0. It's got to start at +1. So let's plot those. 1, 0. So to the right 1, up and down 0. So right there on the x-axis at +1. And then to the right 2, up 4. Which would be A, right? B looks similar, but the B option, its first point is over here to the left of the origin, which is what we don't want. Okay, so that is it for 6.1, which is why we're also going to knock out 5.4 today. Which is constructing and simplifying what's called the difference quotient. Okay, what the difference quotient does is helps us find average slopes of things that are not straight lines, right? If you're finding the slope of a line, you're just looking at the rise over the run. Remember, if a straight line, that means your function is linear, which means it looks something like this. Where your x is just an x. It's not squared, it's not cubed. That's always going to make some kind of straight line. Where I can look at this right here and tell what the slope of that line is. If your function is linear, this side right here is called your mx plus b, where the number in your m position is your slope. The number hooked onto the x is the slope of the line. Well, like I said, the difference quotient is going to help us find the average slopes of things that are not linear, which means my x is going to be squared or cubed. But this helps us in numbers 1 and 2. Just knowing that mx plus b talks about linear functions, and the number hooked on to the x is your slope. Look at number 1. The function is f of x equals 3x minus 7. And it's asking me to find the difference quotient for 3x minus 7. Or in other words, what's the slope going to be? Which means my answer should come up and be 3. Now, we're actually going to construct and simplify the difference quotient. It's a long roundabout way to come up with this 3, but it's also going to give us the practice that we need once we get to numbers 3, 4, and 5, where it's not just an x, it's an x squared or an x to the 3rd. Here's the difference quotient. So there's the difference quotient. F of x plus h minus f of x. And the denominator of the difference quotient is an h. here's how you, once you have your function, construct and simplify the difference quotient. This says the first thing we need is f of x plus h, which means go to your function, and wherever you see the x, what should you put in its place? X plus h. So that's what I'm going to do first, is you rewrite the function. Wherever you see an x, you put an x plus h. So again, it's this exact same thing, but instead of x, I have x plus h. The second, so I'm done with this part. Now I'm going to say, okay, minus the actual function. So minus, what's my function? You put in parentheses exactly what this is. So we're just going to work with the numerator for now. We're going to, at the end, once we get this top simplified, we'll throw an h in the bottom at the end, right? There's nothing, this right here is going to be the easy part. It's just an h. But we have used our function here. So let's simplify what we have by removing the parentheses. So I'll distribute the 3 here. So 3 times x gives me 3x plus 3 times h is 3h. Bring down the minus 7. To remove these parentheses, I'm going to distribute that negative. When I distribute negatives, it just changes signs, right? So these signs are going to change. What that is going to do is make everything in here that has a sign change cancel something up front. Because what does it do to this 3x? It turns it negative. What does it do to the negative 7? Turns it positive 7. So everything that you distributed a negative to should have a matching thing up front with the opposite sign. So this positive 7, there should be a negative 7. This negative 3x should have a positive 3x to cancel. So what's the only thing that's left in the numerator? 3h. Now, what's your denominator of the difference quotient? H. What happens to the h over h? They cancel. So again, what did we know that it was going to end up being? 3. But we need that practice for when x has become squared and cubed. Let's look at number 2. It's another linear one, but I want to do one more like this to just get the practice of using the difference quotient. The function is f of x equals negative 5x plus 6. So again, since it's linear, I should come up with this number right here as my answer. The first step is to rewrite the function and replace its x with x plus h. If I do that, I'll have negative 5. Instead of x, I have x plus h plus 6. And then minus, in parentheses, your exact function. So negative 5x plus 6. And then we're going to clean that up by distributing the negative 5 here and the negative there. This becomes negative 5x, negative 5h. Bring down my plus 6. Now remember, distributing the negative here is going to turn that to a positive 5x and this to a negative 6, which both of these should find something to cancel up front. So the negative 6 cancels the positive 6, the positive 5x cancels the negative 5x. So all you're left with is negative 5h. Your denominator's h. And the h's cancel. So you're just left with negative 5, like we knew that we would. Now let's look at number 3. F of x equals x squared plus 7. So, write the function. Instead of this x squared, I'm going to have x plus h squared. And I'm replacing that x with x plus h squared plus 7. So there's the first part. Now I will minus in parentheses the whole function, x squared plus 7. Now, I'm going to do this part off to the side and then keep it handy. I'm going to circle it and star it so that, because what does this mean? X plus h squared means x plus h times itself. So I'm going to have to FOIL that. Okay, so I'm just doing this part right here, which is the x plus h squared over here. So I've got to FOIL. X times x gives me x squared. My outer x times h, just xh. My inner h times x is hx, but then I noticed that this is the same thing with just the letters flip-flop, so they are like terms. XH and HX are like terms. You just have to have the same letters with the same exponents. They don't have to be in the same order. So I'm just going to go ahead and write it like this first one, right? So I just wrote this as XH. And then my last H times H is H squared. So like we just talked about, these are like terms in the middle here. So you actually have 2 of these, right? Because you have 1 here and 1 here. So you've got 2 XHs. So I've got x squared plus 2xh plus h squared. So that's the only, even though my next problem, I'm going to have to do the same thing. This is what I'm saying. You need to star that, because you don't ever want to have to, you've done this now. You don't want to have to do it every time that you see an x plus h and you have to square it. Just do it once, and then now every time I see it, I just say, oh, that's x squared plus 2xh plus h squared. Right? You just go plug it in. Now, plus 7 comes down. The minus distributes, so minus x squared minus 7. So just like the last ones, anything you distributed this negative to should find something up front to cancel. So this minus 7, there should be a plus 7. The minus x squared will cancel out the plus x squared. So look what you do. This time you have 2 terms left. 2xh plus h squared. The only terms that you're going to have left are going to be the ones that have h's in them. My denominator is always h. Now I can simplify this. Like I said, the only terms that are going to be left all of them are going to have h's in them, which means you can pull the h out as what's called the greatest common factor. I can pull this h out, put in parentheses what is left. If you take an h out of both of those terms, if you take the h out of this one, what's left? Just the 2x plus, if you took an h out of h squared, you still have an h, right? You just took one of them out. Why did I pull this h out in order to simplify? Because again, what's your denominator? H, cancel, cancel. So all you have left is 2x plus. So again, all this right here, I'm going to just remember that I don't need to do that anymore. Anytime I see that squared, I'll just be able to plug this in. Like on my next one. Oh. Which is f of x equals 10x squared plus 2x plus 4. So this time, everywhere, remember the first step is to rewrite your function. Everywhere you see an x, you're going to plug in x plus h. So there's 2 places this time. So let's see. I'm going to start off with 10. Instead of x squared, I'll have x plus h squared plus 2. Instead of x, I have x plus h plus 4. So there's the first part, right? I've rewritten the function. In the 2 places I saw x's, I put x plus h's. The second part is minus, and then in parentheses, you write the exact function. So minus 10x squared plus 2x plus 4. So here, I'm bringing down this 10. Now remember, this is why we kept it. Right? Anytime I see x plus h, but it's squared, I'm going to plug this in. So x squared plus 2xh plus h squared. Then how do I get rid of these parentheses? Distribute the 10 to all of them. So 10 times x squared is 10x squared plus 10 times 2 gives me 20xh plus 10 times h squared is 10h squared. That took care of this. Now I need to get rid of these parentheses, so I'll distribute that 2, which will give me plus 2x plus 2 times h is 2h. So distributed, got rid of those parentheses. The next thing is just bring down that plus 4. And then remember, the negative actually helps us out a lot. When I distribute it, it's going to make all 3 of these terms opposite signs and cancel something up front. That makes this a negative 10x squared. Turns that into minus 2x and this into minus 4. So again, everything I distributed -2 should cancel something up front. So -4 knocks out the +4. -2x. There's the +2x. -10x squared. Here's the +10x squared. And just like the last one, all the terms that are left are going to have an h in them, right? I've got 20xh plus 10h squared plus 2h. Since it's over h, and I notice those all have h's, I'm going to pull an h out of the top so I can use it to cancel that denominator. So if I take an h away, you just rewrite what's all those terms less an h. So this one will just be 20x plus, this one loses an h, so it'll just be 10h. Plus, this one loses its h, so it'll just be 2. And again, I'm just bringing over that h in the denominator, so the h is canceled. So you're just left with 20x plus 10h plus 2. Last one. The mistakes made on these problems are always very simple, minor distributing mistakes or something like that. But also another good way to catch a mistake though is if what you distribute negatives to, if all of those terms don't cancel a term up front, then there's something wrong. Right? Everything that you distributed negative to cancels something up front. All right, let's look at the last one. F of x equals 3x to the third. So just like the last ones, the first step, I think it's only one term, is to replace this x with x plus h. If I do that, I have 3 x plus h to the third. It doesn't seem bad yet. So I'm taking care of that. Now minus the function, which is 3x to the third. So now, instead of x plus h squared, which we have saved, we're going to need to know what x plus h to the third is. This is also something you're going to want to save because you are for sure not ever going to want to do this out all the way again. Because what does x plus h to the third mean? Which means FOIL these two together, get your answer, and then distribute that answer to that last x plus h. So we can take a small shortcut because we have already done this, right? We did x plus h times x plus h and got that. So I can take kind of a small shortcut because I know what x plus h squared is. It's x squared plus 2xh plus h squared. So that took care of multiplying those together, but now I have to multiply this times that last x plus h, which means everything in the front parentheses distributes to both of those terms in the last parenthesis. But remember, you're just going to do it once and then you're going to save it. Actually, you're just going to watch me do it once. So x squared goes to both of these. X squared times x gives me x to the third. Then I have x squared times h, which is just x squared h. So I'm done with the x squared. Now I move to the 2xh and distribute it to both of these. So what's the first thing I have? I've got 2xh times x, which means the x's are going to end up being squared, right? Because you got x times x. So what's this going to end up being? Plus 2x squared h. So that distributed to the x. Now I need to distribute it to the h. So this time, who's going to end up being squared? The h. So I'm going to have plus 2x h squared. So I'm done with that. Now the only thing I have left to do is distribute this h squared to both of those. So let's see, h squared times x is just that, x squared h. H squared times another h gives me h to the third. Now, let's clean it up. There are like terms. There are not any other x cubes. But look at these. They're both x squared h's, x squared h's. So how many? You've got one here and two there. So you actually have 3 x squared h's from putting these two terms together. Same with these. They don't look like terms maybe, but uh-oh, I messed up. I wrote this one wrong. Did y'all notice that? Yeah. You did? No, I was wrong. Because that came from this, right? H squared x. So h squared x. So that's where my mistake was. I put the x squared instead of the h squared. But these are like terms. There's 2 here and 1 there. So you actually do have 3 x h squareds. And if you write that as h squared x, that's the same thing. It's fine. Plus h to the third. So now you never have to do that again, because anytime you need to cube x plus h, you're just going to fill in x to the third plus 3x squared h plus 3hx squared plus h to the third. Anytime you see this, right? So again, we've done it. We've saved it. We don't have to do it anymore. So what am I doing here? I have 3 instead of x plus h to the third. I plug in this. So x to the third plus 3x squared h plus 3xh squared plus h to the third. So all I've done is brought down this 3, brought down that. So I still have minus 3x to the third. So I'm going to distribute this 3 to all of those. So let's see, I've got 3 x to the third plus 3 times 3 is 9 x squared h plus 3 times 3 again is another 9, but this time x h squared plus 3 h to the third, then minus 3x to the third. So the only thing that's going to have something to cancel, remember, the only thing that has things to cancel is what you distributed the negative to. So this one just should have a positive 3x to the third. So what do we have left? We've got 9x squared h plus 9x h squared plus 3h to the third. So once again, they all have h's. So pull the h out. Put in parentheses what's left if you remove an h from all three of these terms. So this one will just be 9x squared plus 9x. If I took an h away, I still have an h. Plus 3. If I took an h out of this, I still have h squared. Again, your denominator's h, which means your h's cancel, and what you're left with in parentheses is your answer. Okay, so we squeezed it all in right on time.